Welcome to my lab, where we study the tiny components that keep our world running smoothly. Meet the resistor, the quiet traffic cop of the electrical world. Did you know? Resistors are found in almost every electronic device, from your microwave to the advanced satellites orbiting Earth. Before we had the resistor, electricity was like a wild storm that couldn't be tamed. Early experiments often resulted in unpredictable and dangerous sparks. Did you know? The Leyden jar, invented in 1745, was one of the first devices used to store static electricity, but it had no way to control the speed of the discharge. By the 1800s, engineers realized they needed a way to slow down the flow of power to protect their inventions. They began a global search for materials that could resist the current. Did you know? Georg Ohm, a German physicist, was the first to mathematically prove the relationship between voltage and resistance in 1827. Thomas Edison used a thin carbon filament as a resistor in his famous light bulb. This resistance created the heat that made the filament glow bright. Did you know? Without resistance, a light bulb would simply short circuit and explode. The resistance is what creates the light we see. Imagine electricity as a massive crowd of people running down a wide copper highway. The resistor is like a gate that narrows the road to keep the flow safe. Did you know? Conductive materials like copper have very low resistance, while insulators like rubber have extremely high resistance. We use a special formula called Ohm's law to figure out exactly how much resistance we need. It is the most important tool in an engineer's toolkit. Did you know? The formula is V equals I times R, where V is voltage, I is current, and R is the resistance measured in ohms. Resistance is just like a narrow section in a water pipe. The smaller the opening, the harder it is for the water to get through. Did you know? Hydraulic analogies are the most common way for scientists to explain how invisible electrical forces behave. Think of the resistor as a bouncer at a club entrance. It checks the electricity's ID and only lets a safe amount pass through to the next component. Did you know? Components like microchips are very sensitive. If too much current hits them, they can melt or stop working forever. This LED is glowing happily because its resistor friend is standing guard. Without it, the LED would receive too much power and pop. Did you know? A typical red LED only needs about 2 volts. If you connect it to a 9-volt battery without a resistor, it will burn out in milliseconds. Inside this little striped cylinder is a ceramic core wrapped in a thin spiral of carbon. The path of that spiral determines how much it slows down electricity. Did you know? Carbon film resistors are made by carving a spiral groove into a carbon layer. A longer path means higher resistance. Resistors are too small to have numbers printed on them, so they use a secret language of colored bands to tell us their value. Did you know? The standard resistor color code was established in the 1920s to make it easy for technicians to read parts from any angle. Each color represents a number. For example, brown is 1, black is 0, and red means we multiply the value by 100. Did you know? A resistor with brown, black, and red bands has a resistance of 1,000 ohms, often called 1 k-ohm. When you turn a volume knob, you are using a variable resistor. You are sliding a metal arm across a track to change how much sound flows through. Did you know? Variable resistors are called potentiometers, and they allow us to control everything from volume to light brightness. Some resistors are sensitive to light. When it gets dark, their resistance changes, telling streetlights to turn on automatically. Did you know photoresistors, or LDRs, are made from cadmium sulfide, a material that becomes more conductive when light hits it? The last band on a resistor is usually gold or silver. This tells us the tolerance, or how close the resistor is to its perfect value. Did you know? A gold band means the resistor is accurate within 5%, which is very high quality for standard electronics. Stopping electricity creates heat. Large resistors often have metal fins called heat sinks to keep them from getting too hot while they work. Did you know the heating element in your toaster is actually a giant resistor designed to turn electricity into heat on purpose? Inside your smartphone, there are thousands of resistors that are smaller than a grain of sand. They are placed by super fast robotic arms. Did you know? Surface mount resistors, SMD, are so tiny that they don't even have color bands. Their values are sometimes printed in microscopic text. Before we finish a project, we use a multimeter to measure the resistance. It's like a scale that weighs how much the electricity is being slowed down. Did you know? Modern digital multimeters can measure anything from a fraction of an ohm to millions of ohms with incredible precision. Whether it's a tiny toy or the massive power grid that lights up our cities, resistance is the key to managing power safely. Did you know? High-voltage power lines are made extra thick to reduce their natural resistance and prevent energy loss over long distances. Understanding the resistor is your first step into the amazing world of electrical engineering. Please like, subscribe, and share this video with students, parents, and educators to help grow the channel. Did you know? Electrical engineering is one of the most diverse fields, covering everything from robotics to renewable energy.